Magnets have many uses, and in other lessons I'm going to cover the really tricky ones, the motors, the generators, the transformers. Back in the lessons on electrical safety, I covered the magnetic relay, and perhaps you might want to look back at it now that you've got some understanding to see how that really works. In this lesson video, I'm going to look at the electric bell, which has got very many similarities to the relay. But let's get going with this one. You can see one here. You press a switch and the little ball hammer here strikes the bell repeatedly to make a loud sound. Maybe you have these as your doorbell or school bell or fire alarm. Let's look inside. We've got a bell, B, on the left, ready to be hit. Below that is the hammer, A, which can pivot over here. The circuit starts at the battery, goes through the push switch, round these coils that are wrapped around the electromagnet, along the brass contact plate and through the screw, back to the battery. Now, what happens with this is the coils will generate a magnetic field like so. Whoever drew this forgot to put field lines on. If you remember how to use your right hand grip rule, give it a try. Which way do the field lines go? Look at the left coil first. Which direction is the magnetic field? So the current is flowing around the back at the bottom here, then around the front. In other words, it's going right to left in front of the core. And you need to twist your body or shoulder around a bit to do this perhaps, so the field is pointing downwards. That must be a north pole there because the field is pointing away from it. How about the other side? It's good practice this, because you should see that the current at the front is going left to right this time, so the field is pointing up. We have a south pole here. And now I can draw the arrows on the field lines. Right, so where was I? The magnetic field attracts this piece of pure iron, pulling the hammer up, hitting the bell. Excellent, that gives us one ding. It also breaks the circuit. This cuts the current, so we aren't going to get the magnetic field anymore. If there's no magnetic field, the hammer will spring back away from the bell, and we're back to where we started. The contact is touching again and the process can repeat. Current flows, generating a field, attracting the hammer and breaking the circuit, stopping the field, letting the hammer go back, and so on. As long as the switch K up here is being pressed, it will keep going. This simple application makes good use of electromagnetic theory and circuits. It's also a good bit of practice for sequencing, for putting things into an order, into steps. So go back and check that you understand the sequencing on this, and then maybe look at other things. Like I said, go back to the relay, go and look at loudspeakers, look at that big magnet that can be used in scrapyards to pick up cars. Can you sequence the order of events that goes into making those applications work as well?